output, enter the text you wish to encrypt. We'll type in hello, and there we go. We have a text, we have the number of the positions we have shifted, and the ciphered version of hello. For those of you who are not familiar with what Caesar Cipher is, we'll just go over the theory of what it does, and then we'll move on how to write it in Python. Looking at this website here, the link will be in the description so you can look at it yourself. Caesar Cipher is a type of substitution cipher in which each letter in the plain text is replaced by another letter at some fixed position from the current letter in the alphabet. So if you can imagine one alphabet written in front of you, so all the letters from the alphabet, and if you shift each letter by a certain amount of positions to the right, let's say by 3 positions, each of the letters in our plain text will be replaced by a letter at 3 positions to the right of the letter in plain text. To simplify it even more, this example, letter A will become C, letter B will become, can you imagine which one? D. So this we would encrypt our message. And now we will move on how to write a code that will ask the user to input any text that they want, and our code will actually then encrypt that message using the Caesar cipher. I want to share this experience so that other people can learn as well. So there will be no point in me just writing this code without explaining exactly what it does. How do you even get to the idea of using a certain aspect of this code? But also I wanted to approach the whole logic of how do we see a problem and a solution to a problem. So we'll go through a little bit of theory first, and I want to think about, well, how am I going to approach this code? What exactly do I need? So we will analyze this problem. The first part that I want is that does the encryption. So I want to write the function that will actually do the work of encrypting the message and then giving that back to the user. So I've decided that I will write this Python code in 2 parts. The first part will be the function that does this encryption, and the second part will be sequence of instructions which will actually get the input from the user for the text that needs to be encrypted, and then the print functions that will display output all this information. Before I start writing this code, I want to have a clear plan. What exactly do I need? So my function will need 2 variables as parameters passed within the function. One of those will be for the text, which is actually the input we will later ask from the user. So I'm talking about being able to input the user for give us the text that you want to have encrypted. And we will immediately define this variable, store this in a variable called text. And the second variable will represent the step of by how many positions are we moving in our encryption method. So what exactly do I mean by this step? We're going to go back to the article here. So what we said earlier, if we wanted A to be represented as C, how many steps do we need to the right? It's 3. So that's the variable that we will be using as one in our function. Then we'll move on. I know that I will need an empty variable, which will be later filled with our for loop. It's here, we're going through the theory first. It will make much more sense once we actually start writing the code according to this plan. So our for loop will dissect the text variable and pick up each letter that the user has inputted and wants to be encrypted, and then store it in a new variable which we will call char. We'll call it char. The last part of our function will include conditional statements, and the purpose of these conditional statements will be to determine whether each individual character in our char variable, if you remember, char variable is going to be each individual letter from the variable text, and variable text is actually the input from our user. That input is the text that the user wants to have encrypted. These conditional statements will determine whether the character in char variable is upper or lowercase. Simple as. And then, and this is the most important part, we will need to apply the mathematical representation of Cipher Caesar code to each letter. So in a way, is going to apply this mathematical representation of cipher code to each letter. The Caesar cipher encryption rule can be expressed mathematically as, and then let's explain actually what this does. So as we can see here, we have the variable called C, which represents encrypted Caesar cipher code. So then the X will represent the letter that we want to be encrypted. N will represent the number of steps we want to make. It will be calculated through remainder of 26, which is the number of letters in the alphabet. Starting with everything, define function, we'll call it encryption. So just ENC, that will do. And as you can remember, we need two variables inside of our function. So we have just covered this part here. We move on. Our empty variable, which will later be filled with the for loop, we'll call it empty. Moving on. Now we write our for loop for I in length of list. This part is our char variable. What we said, this will actually dissect the text variable, which we called list here, and pick up each letter and store it in this new variable called char. This is where we end up now. Char equals single L of list. Moving on, we write our conditional statements, which determine whether the character in char variable is upper or lower. If char is upper, in that case, we want to add this character into our empty variable over there. We are moving now to the very, very important part of how will we make our Python code to instruct our code to recognize a certain letter of the alphabet and then encrypt it. We will be using Ceasar and ORT. Shortly, we will try to explain here using the article we already looked at. When we look at the ORT function, the explanation for it is that it converts a character to its numeric representation. It accepts a single character and returns representing its Unicode. So the reason why we need Unicode is because Python can't recognize letters that we get from our input of the user. Every letter has its numerical representation, which is part of the Unicode. So we actually need, in order to convey to Python, okay, I need this letter converted to Unicode or vice versa. So we are going to move on and use these very useful methods, CHR, and then, do you remember what we used? Each element, CHR, odd, and then we want that to be applied to each element in our list. And now to add the step that we will encrypt our letters, we use our variable 65. The remainder 26 plus 65. We do the same thing for lowercase. We already have if it's an uppercase, and if it's not an uppercase, then else. And then we repeat basically the same thing. We will use different numbers. I have already looked this up online. I'm not going to lie. This is the way how we access these letters in Unicode. Remainder of 26, number of letters in the alphabet, plus 97, which is where the lowercase letters start in Unicode. So now we have finished our conditional statements. We have our for loop, and the only thing left is the function ending with returning the empty variable earlier defined for the purpose of being filled out by our for loop. So we want return empty, and that should be it. And now we want to define the input from the user in our list variable. We want the variable which is step. You remember what we said? The way this Caesar cipher works altogether is by moving the position of the alphabet by a certain amount of steps. So we can choose 3. And now we just want our print statements to output the result of everything that we have done here. So we want one print statement for the text that has been given by the user. So we have a list. We want another variable that will show by how many positions are we shifting the new alphabet. And remember, because this is an integer and we are trying to print it, we will have to convert it to a string. And then lastly, we want the actual encrypted message to be displayed, and we will call our function, and that should be it. Okay, quick fix of this. We have our code, so it's time we try to running our code. We have the output, enter the text you wish to encrypt. We'll type in hello, and there we go. We have our text, we have the number of the positions we have shifted, and the ciphered version of hello. Now we can try maybe changing the number of positions that we will move. We'll put under our step variable, we'll put 6 and see how hello looks now. So this now is our version of hello when we have shifted 6 positions. We can try maybe writing something else. Just hello, how are you today? And this encrypted ends up being, I can't even pronounce it if I wanted to, but there we go. Today we will be writing a program which will calculate the distance traveled by an object moving with constant acceleration. So over here we have our formula. Once we have received values we need, we can implement them in a formula that will calculate the distance. So in further explanations, we have that our program should prompt the user for values and then return the actual result. Let's do this one. First thing we want to do is import math. We will rely on something that Python offers us when it comes to raising the power of numbers. What we want to do, as previously we have practiced, how we get input from a user. Input, and we ask for initial velocity. Now I ask you, what is the best way to keep this stored in Python once the user actually gives us the answer? Well, very simple. We will store this in a variable. I will call it initial velocity. And to make our life easier, we'll do this now and convert it into a float simply by writing float and putting everything in parentheses after that. So now this should ask the user for initial velocity, which can be anything, and we know that so far everything works. Continuing with the information we need to ask the user for the amount of time that this process has taken. So we'll do the same now, time taken, and then we'll do acceleration. So the first part of our program is done. Oh, sorry, error could not convert string to a float. That was me trying to input text. Obviously the user will be inputting numbers. There we go. I'm trying to contradict myself. I put float here and then I'm giving aka text as a response. So it gave us that error. Once we give actual numbers, we know that everything works fine. So the first part of our program works. Now we want to take the formula and let's see again what it was. Okay, so this is our formula and it will equal initial velocity multiplied the amount of time that it took to move. That will be added to acceleration times time taken squared, and that will be the half of that value. Okay, so we have our initial velocity, time taken, need to add it to half of acceleration times time taken squared. To be smart, and you know how it's easiest to be smart today? We will Google this as well. No, there's no need to Google it. Okay, now let's try just printing our formula because that's all we need. So initial velocity times time, and then this should be added to the half of acceleration times time taken. So that should work. And this, multiplied acceleration and then the squared power time taken to the power of, I believe we have written our formula. Take initial velocity 5, time taken 10 seconds, acceleration is 15, 800. And that's it for our time distance calculator. And basically we are supposed to write a code program that will calculate break-even amount. And what this means is that we are given this information: how much it costs to produce each item, how much we sell each item that has been produced. Then we have fixed costs, profit per item. That gives us 2,500 items have to be sold to break even. Quite simple, isn't it? Very simple, but let's do it in Python. First, we'll start by storing all the values. So our values were cost for each item, which was 20, sale price 40, our fixed costs were 50,000. So obviously per item was minus cost each item. So simply we have stored all you can see on the top. The simple formula for calculating profit per item is simply deducting the cost per item from the sale price. So if we were to print profit per item, it should give us 20, logically. So now moving on, we get our break-even formula. Once again, we need to find out how much items we need to sell before we break. That should be too complicated, so we will create another variable called break-even, and the formula will take our fixed expenses and divide them by. So if we were to print break-even now, we get asked from us, as you can see, 2500. So we want to create a program that will give us this output. So we have that aspect for string manipulation. We will try to create an output that gives us this nice text actually explaining what is what, not just giving us numbers. So out of this tutorial will be to do just that. We will delete this and start writing our print commands. We start off with cost to produce each item, and we will close off the quotations here, effectively ending the string, and then include our cost per each item. I'm going to leave this converting it first to print this statement. So we get an error, and if we look at the explanation, it gives us type error can only concatenate string, not float. So Python, being a programming language, is right away explaining to us that print statement executed is if we convert our problem here. So we will do and type in plus str, so inserting str, and then whatever we put into parentheses after that is going to be converted into a string, and that's how we fix our error of not being able to concatenate a float. So str and cost each item, and there we go. The same thing for the rest of our convert to string, and we take second part is there of filling everything in. Fixed cost, and lastly the break. So we have a teacher who has bought a packet of 40 sweets, and she plans to share this amongst 14 students. Because a single sweet cannot be shared, the teacher will keep what not given to the children. The teacher will keep the minimum number of sweets possible. So we need a program that will create an output that will tell us how many of sweets child will receive, also giving us the information of how many sweets remain in the hands of the teacher. So as a single sweet cannot be shared between pupils, the program must calculate and output the number of sweets per child and the number that is for herself. So it is a female teacher. Okay, the calculation must be done using the remainder operator. So let's start writing in Python. So let's store the information that we were given in the actual instructions. So we have 40 sweets and we have 14 students. So we have stored this as our variables here. Remainder can be calculated quite easily, dividing number of sweets with the number of students. So let's see what if we print remainder. It was 14 students, not 4. So if we print a remainder, this number is telling us how much of sweets are left in the hands of the teacher. So we know that 28 sweets can be distributed equally to the students. So the next part is as deducting the remainder, the number of sweets that the teacher will be able to keep for herself, the total amount of. So we have sweet, and we are deducting the remainder, the 12 sweets teacher keeps. So 28 in number of sweets that can now be equally distributed to the students by the teacher. And our simple number of each student gets is assuming the total number of sweets that can be distributed. So if we want to print this, we will go. So this is the maximum number that each student can receive, and our number of sweets that the teacher keeps to herself is 12. Simple as that. You got a lot of Python. That's our problem solved. So this is our shape. It's not just a it's not a square, it's not a box, it is a cuboid. Our program needs to calculate volume and surface area of this. Even most, our program will ask the user to insert the dimensions for this shape, and then according to the dimensions given, we'll do calculation for volume and surface area and return this to the user. So without further ado, let's move to Python and let's write our code. So first we want to, as usual, ask the user to void width, and then the same length. So far, and you should recognize if once user has been asked to do these things, Python actually remembers their answer and stores it as a variable. So we will actually do that by writing height and length. To make our life even easier, I'm going to do this, and we will convert a float. Oops, sorry. There we go. So this is, and we will define another variable for our calculation for the volume of this object shape, and it should be quite simple. It's simple as multiplying these three values. So we can rely on our previously defined variables. We'll put in width 8, height 5. This is true. So that's our formula for our cuboid volume. And now we're going to do the surface area, which should be the square footage. So I'm not going to pretend I'm smart. I googled this formula 5 minutes before making this video. Anything from Google, feel free to do it. By all means, that's what I did, so I can immediately tell you that this is the way to get that formula. Essentially what the formula is taking each dimension, multiplying it with the dimension, the third dimension, and then adding those three up. Simple as. Then to get the square footage, that number squared is our answer. Voila. So quite simple. That's why we have written here, because the total number will be multiplied by itself if we do the 2 times. So we will now start length times height. So we have one of them. We want to add them up. So now width times height, and last one times width, I believe. I think that's it. And now we print. So let's see, does everything. So 5 meters, and this is 6. And we have an error, which is great whenever this happens in our video. Why? Because I get to revise and you get to learn. Win-win. So it's in line 6. There we are. must float. So I see where it was. It was in nothing more than just errors. We'll rewrite this. So it was a simple typo to learn from here other than my incompetence. So length times width. We have the same thing now. 5, 6. Lovely. Program that inputs the user for these dimensions, and then have the formulas and the surface area of this shape. Move on to our next problem. We want to create a imperial converter. So this is the text that we are dealing with. So we want to write a program that asks a user to input their height, so in feet and inches. And then we want our program to convert feet and inches into kilometers, meters, centimeters, millimeters, etc. So the output should be a conversion of these values. We have an example here. If the user enters feet and inches, this value, the program should output that same value, but convert it into kilometers, meters, centimeters, and millimeters. So let's see how we achieve this. We will move this a little bit on the side. And let's see what we can do. So the first thing we want to do is ask the user for some input. They will give us height examples. So float input, and we ask the user, what is your height? And they should give this only in feet for the sake correctly. And then we do the same for inches. And now we'll do the mathematical part of our code. So first we want to do conversions to kilometers. How do we do that? We want to take a new variable and we'll take and divide that by 3281. Then we want to do a new variable, inches in kilometer, user inches variable, and divide that by number 9370. A good question now would be to ask, where did I get these numbers that I'm dividing them with? Google. Yeah, I'm not also, I just Google do this, and the exact same information that I'm inputting here, I got it off there. Our kilometer, want to round it up to 6 decimals. I'm looking at the text that they gave us in the exercise. So we'll write in round, and then kilo plus inches, do it by 6. So this should now, if we print, it should give us a conversion. Which values? Well, obviously 5 feet and 10 inches, and it matches we were given in tutorial. So this seems to work just as we want to. So now we want to use the same and convert to meters. Again, we will Google how to convert this in terms of what number to use when dividing the feet and inch values. When Googling it, we will see that we can do it by dividing it by 3.281. For inches, in meters, we'll do it by dividing it by 39.37. Once again, this is from Google. And then stored as a variable, we also want to round it up by 4 decimal points. Once again, why am I rounding it up to a specific number of decimal points? Because I'm trying to mimic the output they expect us to create in the tutorial. Following the same concept, we will do conversion to centimeters times the number is 305 inches, and the number is 25. Sorry, this number is not 305, it's 3048. We have centimeters, and we don't need to round this up. Let's see how we are doing so far. If we input the same values from R to top, what do we get when we print km, m, and centimeter? And it looks like we are getting the same as it was stated in our tutorial. So this is how we verify our results. And now we will do the last one, which is conversion to millimeters. We are defining new variables to represent these values in millimeters, and we follow the same concept. We're using the numbers from Google when it comes to knowing how to convert, which number to multiply with. Then inches, millimeter, 25.4. And our millimeter variable will be the previously defined millimeter plus inches in millimeter. Now we have the mathematical part for doing these conversions. We want to return these results to the user in a form of, we'll do our print commands here. So height in kilometers and we will convert to string and kilometer this many times. This will be meters. We'll make sure that the variables are new, and that should be it. Let's see, does everything match the text from our tutorial 5 and 10? And I believe we have the same value, and this is our imperial converter. These are 3 great exercises for pure beginners in programming that want to learn how to use for loops. And not just that, for any beginner that actually wants to see how to use for loops in a very simple exercise, we'll do that for them. So in our first exercise, we want to literally draw a grid that a user can kind of choose the rows and columns, so they get to decide how this grid will look like. So we'll start with our code. Call the first variable just first. We'll make it an integer, because the user is going to choose a number of our rows for grid. So input, and then we'll practically do the same thing. We'll rename the variable count and row into column. So this part of the code will ask the user to input the values. So now we want a variable that will define what will be the drawing block of our grid, and we'll just choose star sign. And then we want kind of like the formula, which will be the drawing function program. So as simple as a second variable multiplied by symbol variable, which is sign. So these are all the values we need. And now we will create the for loop. So in order for this grid to be drawn in Python, we need to create a for loop that will take these values and do it a certain number of times. So we will create a for I, so for each element in range of the column number. And we will put a nested conditional statement saying that if the this should be the column number is greater than 0, then print column. Print column formula. So if the row number and the column number is greater than 0, we want Python to print for this many times this formula. Column number times this. So let's see what we have. And we run the code, enter your row number, it's 5, and column number 3, and we have 1, 2, 3, 4, 5, and 3 columns. So it does what it's supposed to do, and we will move on to our second exercise. For our second exercise, we want to create a program that will take a certain amount of numbers and add them all up. But we want to use a for loop to then pick numbers that are positive and negative, separate them, and add them together as a separate positive and negative sum. So we will start by creating an empty list, and then I will pass a variable called number of elements, just to make it easy for remembering. Asking the user to choose how many integers do they want to add up. So how many numbers do they actually want to add up all to. So this will ask the user for the number of elements to be added up. And now we start with our first for loop, and it will be for every element in range of number of elements. So this is the variable we just passed. Basically, the input that the user gives here will be stored in this. So now our for loop is going to take the number of elements here because it's the range of these elements. So new variable called elements. Again, asking the user to enter their number and press enter, so they can continue entering the numbers that they want. So now we will use function that will append any answer in this question will be stored in a variable called elements. And this function will append numbers into called elements. So that's the first part of our program. In the second part, we want to create 2 empty lists. One list will be for our positive numbers, and the second list will be for our negative numbers. So first, with our empty lists, and then for the positive numbers. So you will see later append method. So now with our second for loop, for every element in list. So if you remember earlier when we made list literally at the beginning of writing, So now I'm going to write for every element in list nested conditional statement. If that element is less than 0, means if that element is a number, automatically that's a negative number. So we want to append it into the list of negative numbers, the empty list we just created earlier, as you can see. So for every element, if that element is smaller than 0, we're going to write a function that will append that number into our empty list called negative numbers. Choose append that element. And another conditional statement nested into this for loop is going to be if that element is greater than 0, then we want to append to our number of positive. So that should be all when it comes to the actual program. All we need now is sum of the positive integers. We will use the pre-built function sum so that it just basically calculates the sum of the numbers in our positive numbers list. And we'll do the same for negative. And we will just change this bit so it's our negative numbers. So that should be all. So now let's move into our output and see what we get. So we run our program. Choose how many integers you want to add up. Let's choose 5. And we'll start putting in our numbers. So 5 minus 3, 5 minus 6, and 3. So the sum of the positive integers is 13, negative integers is minus 9. So our program works as intended. Moving on to the third and last exercise for today, we are going to take the first exercise and make it a little bit more complicated, a little bit more interesting. So if you remember, we were drawing a grid with a for loop. This time we'll be drawing a diamond and the user will be able to choose what kind of diamond they want. So let's do that. Just like previously, we will choose our sign that we use to create the diamond. So our star, and this will be asking the user to how high do they, and to specify it a bit more, these are some instructions. So now we need some conditional statements to reinforce what we specify to the user. Some if height is greater or equal than 40, then print greater than 40. Make our program a little bit so it's able to greater than 40. Elif is smaller or 2, then print invalid amount less than 2. And if put the desired, we can put that in. Else, if none of the above happen, then simply do this. And now we will use the for loop in order to have written. So it will be for x in range of height, print, and now we will make it neat and sensible. Height minus the variable of element times a little bit of math now, 2 times the plus 1. And we'll write which is the each element in range of height 1 and minus 1 again, print, and basically the same thing like above, times minus the element, it's the same math, 2 times element it. So let's go to we have. So we're gonna run our code, enter your desired. So let's say we want 5 and we have a lovely diamond. If we try to run it again and we choose 25, we have a bigger and equally aesthetically pleasing diamond. So I hope you enjoyed this short and very useful exercises for people who are coming across for loops for the first time. You get to see a practical example of how you can use for loops. And this should also help you to kind of understand the logic of loops in programming and hopefully make it easier whilst you go on to study while loops. So basically we want to ask the user to give us this information. So it will be rent per month, gas, electricity, water, basically bills. And we want our program to add up all the expenses and do it in this neat format that actually makes some sense. You know, it's kind of aesthetically pleasing and readable. So without further ado, let's start with our writing of the actual code. We'll keep this as a point of reference. So how do we achieve this? Well, obviously first we want to ask our user to give us the information that will be calculated. How do we do that? We use input, and it will ask the user for rent per month. It will ask the user for gas per month, and now electricity. Obviously, for the sake of time management here, I won't, but where you are practiced to make it more believable, knock yourself the tax. So these are our questions. What's the best idea when it comes to us wanting on to store this information? Well, we will store the answer from the user in variables and call them something as simple as this, so we can use them later on. Obviously, I want to make my own life easier as soon as possible and convert everything into a float, because I expect all the answers from the user to be numbers. They're answering about their bills. I know what I expect, so I will put float for that purpose. I will do this water bill and council tax, and also convert all to float just as we previously have. That should be the first part of our program. We will run it just to check that everything works, and it does. It's not giving us any errors, and we can move on. So now we want to write the part that will actually print the information that the user has given us to these questions. So we'll start by doing our print commands. Yes, to make this look the same way how it does in the picture, we want to put backslash the other way around, n. And what this does, it will automatically move the text into a new line. When we do that, we can continue our rent, make our mistake. Rent look fine. We had an extra parenthesis. There we go. That's our first line of code. So we will continue printing gas, and now doing the same thing for the rest of them: electricity, water, council tax, and obviously everything. We will also show that all of our variables are equally. And council tax. Let's see what we have, but we are on good track. To quickly make it a bit neater, let's see how it looks. Much worse, right? So the next thing we want to do now is there is a nice divider before we get our total amount, and we'll do the same thing. So what we can do there is just print and then infinite amount of these, but we can be even smarter about it. We can take 30 and then, wow, we're being so let's see what happens now. There we go. Maybe we're less than 30, 28. Lovely. And now the calculation for everything, which is as simple as just adding up. So we can define that here. The total of everything will be rent plus the electricity plus the water. Do we have plus the council tax? So our total to be used in our next line, which is, let's just do this. It will be and that's pretty much what we have when we run the program. We can add another space here. we have a nice divider to make it written underneath.